Hi there, welcome to a quick video tutorial on circuit analysis. In this video, what we're going to do is combine Kirchhoff's laws, Ohm's law, and our understanding of equivalent resistance and the corresponding equations to analyze complex circuits and determine unknown quantities. If you're watching this video, the expectation is that you understand current, voltage, and resistance, as well as the equations associated with each of these laws. If you do not, I suggest you take a peek at the video lesson I did on Kirchhoff's laws, as well as the equivalent resistance video, in order to fully understand what's happening in this tutorial. So what you're going to be doing is you're going to have some combination of current, voltage, and resistance. You are trying to solve for all of the unknown quantities in the problem. You're either going to be given all the resistances and the source voltage, or you'll have mixed voltages, current, and resistance. The basic idea behind these problems is that you want to solve for 2 out of 3 of the quantities. For example, you have V and we have I. Well, you know what? That's enough information to solve for R. So we're going to dive right into one of these problems. The problem says, given that you have a resistance of 15 ohms, 25 ohms, and 35 ohms connected in series, you've got a source voltage of 12 volts. Your goal is to find I source, I1 to 3, and V1 to 3, as well as the total resistance. The first thing I want to do is I'm going to look at the total resistance for this entire circuit. I'm going to start there because if you take a peek, I've got 1, 2, 3. I've got all of my R's except for my R total. So I do have enough information to find R total. Now, if you think back to your understanding of equivalent resistance, and if you've watched the video tutorial I did on that idea, looking at this circuit, I've got R1's connected in series with my source. R2 and R3 are connected in parallel. So what I want to do is effectively consolidate all of these resistors into one single resistor, which would be my total resistance. So I'm going to pick on R2 and R3 first. Those two resistors are connected in parallel. So I'm going to use the equation for resistors connected in parallel, which looks like this. I'm simply going to substitute in R2 and R3. So I've got 25 for R2, 35 for R3. I'm going to find a common denominator, and I end up with 12 over 175. In order to solve for R parallel, I can simply flip my fractions, and I'll end up with this overall R parallel resistance. I've now taken my parallel branch and I've consolidated these two resistors into one single resistor. If you consider this to be one new resistor, this guy's connected in series with R1. That allows me to use one of the other equivalent resistance equations, which is the one for series. Essentially what I'm going to do is add my two resistances together. I'm going to take this R1 resistor, I'm going to add my new resistance that I just found, and I'm going to come up with a new resistance. I now have R total. I've got V source, I've got R, I've got V. I should be able to solve for I. And I can do that using a little bit of algebra. Substitute in V source, which I know is 12 volts. I'm going to substitute my new R total, and I've got a nice little equation for the current at the source. Okay, well, I've now got I source. One of Kirchhoff's laws says that for resistors connected in series, we know current passing through should be equal. So if I've got 0.4056 amps leaving my circuit, we must have 0.4056 amps passing through that first resistor. I've got an equation for V1. I'm going to plug in R1 and I1. We should arrive very easily at a value for V1. All right, so I've only got 4 values left. Take a look at our circuit. What are we missing? Well, we're still missing I2 and I3. We're missing V2 and V3. We do have R2 and R3 connected in parallel. Since these guys are connected in parallel, we should be considering Kirchhoff's voltage law for parallel circuits. It tells us that voltages are equal. We don't know what these voltages are across these two resistors, but we do know that the voltages are going to be equal. We're going to consider those to be one value, right? We know V2 and V3 are the same, so let's just call them V parallel. And you could consider these connected in series, since I know these two values are equal. Substituting all the values I know for voltage, total voltage is 12, right? That's given in the question. Got V1. This should help me solve for V parallel, and you'll see that I'll arrive at this value for V parallel. Well, that leaves me with 2 currents left over. We've got our voltage, we've got our resistance. We should be able to use Ohm's law to find our 2 currents. For I2, okay, our first current, we're going to just sort of rearrange Ohm's law. We're going to substitute our voltage at the second resistor. We're going to substitute our resistance, and we're going to come up with a current here. Same thing goes for our third resistor. Rearrange Ohm's law, substitute what we know, and you can see here that I've found out both currents. So going back to the original problem, you can see here I've tackled all of the values. That's the idea. It's kind of just like a little scavenger hunt. You want to piece together what you have to help you find what you don't have. So hopefully this helps you understand circuit analysis. It is a tricky concept. It does require a lot of practice. Like I said, you might want to check those Kirchhoff laws videos out again, or the equivalent resistance video. It should certainly help you with analyzing these complex circuits. All right, thanks for watching.